Hey folks, Marco here. It is summer 2024 and this is lecture 2 of our AI Python curriculum. We are continuing from where we left off. As you recall, in lecture 1 we have learned that each node in Comfy is implemented as something called class. We have learned the basic anatomy of a node, stripping the node's code to its bare skeleton. We have then learned how to add input, how to add output. Functions inside a class are called methods. In our example, we made a simple method that assigns input to output, and we tested it with basic workflow to make sure it works. Like any other class, Node may have multiple methods, but what's special about Comfy UI is that there is one and only one method whose name and return types must be declared ahead. That method controls the output, and you specify it using function constant. That is function in all caps, if you recall. Today we are looking at how to employ node widgets as means of supplying input to a node. Before we begin, I do want to thank you all for encouraging comments, upvotes, and shares. Since I am a small startup channel, there aren't too many comments, but at the same time, this allows me to put you on the pedestal and thank you within the lecture itself rather than replying to the individual comments. So you are the earliest supporters of this channel, along with all those who have liked or subscribed. And I have not forgotten comments on Chinese Mandarin version of the video. I do wish to thank the 2 users who have provided me with feedback on the quality of my Chinese Mandarin translation. It appears that AI didn't do the best here. Perhaps I spoke too quickly at times, and at that point AI seems to switch between Mandarin and Cantonese. I think I will try a different approach next time. One user commented that Comfy needs well-documented technical manual. But no arguments from me there. Comfy is technically still in alpha stage of development, as far as I'm aware. Although I started this curriculum with custom nodes to test the waters, so to speak. Once we're done here, I do hope to perhaps make something more introductory, something that will make Comfy more accessible and bring more people in. More people will hopefully translate to more hands helping out with the docs. A very useful feedback came from user AB Week, if I'm pronouncing right. Firstly, please don't feel like you need to clarify or apologize. I follow API, which stands for Assume Positive Intent. Good rule to follow when reading person's email or messages. Look, I went back to check my slides and you are absolutely right. Some of these borders and shapes are way too excessive. I will keep it as one rectangle at a time, given that eyes can only focus at one spot at a given time. In hindsight, I don't really know what I was expecting from my audience. And yes, the background frame is also an issue. Although it is pretty, if I may say so myself, I do find that it leaves me with not much usable space to place content. Nonetheless, I do intend to address these later down the track. And lastly, Andrew Harp has developed a pip package to assist with creation of nodes. I have not tested it yet, but you are more than welcome to. The reason I chose to begin with custom nodes is because I could not find too many resources at the time. With so many channels discussing the latest hype, I felt that perhaps this is something overlooked. It is possible that this package was among the results, but I suspect I mistook it. Comfy UI Easy Node with Comfy UI Easy Nodes or Comfy UI Easy Use. So yeah. Nonetheless, keep the questions, comments coming. All languages are welcome. If you don't feel confident in English, feel free to leave a comment in your language, Japanese, Chinese. All languages are welcome. Personally, I think Hanzi are beautiful, and it's no wonder calligraphy is therapeutic. I think AI has the capacity to bring us closer together, to bring down language barriers and democratize human knowledge. As for where to leave the comment, the channels I currently monitor are YouTube, these 2 subreddits, Civet AI, and as of a couple of days ago, I also made an encrypted mailbox. I won't pronounce it, and please don't type it up publicly, otherwise these crawler website programs will fetch it and I will end up on someone's spam list. So with all that said, let's begin. Before we begin, let's establish some terminology. I will use KSampler node as an example here, since everyone is familiar with that one. As you know, when you right-click on a node, you often find option called Convert Widget to Input. However, as we have discovered in previous lecture, Node's internal function does not discriminate between these two. These are all passed on as arguments regardless. So when you say I am converting widget to input, you are kind of implying that widget is not input, but you can clearly see here that it is. So for purposes of our discussion, let's agree that nodes have two types of inputs: connection input, which we introduced in previous lecture, and widget input, what we are focusing on today. Again, just to clarify the terms I completely made up, I am calling these connection inputs since data is passed on from the node it is connected to, and I am calling these ones widget inputs because they come from widgets. I swear I'm not trying to complicate things, just trying to add some clarity, that's all. With all that established, let's go back and create a copy of our blank node from before. I will just copy-paste code, and to avoid name conflicts, we give it some new name. Since we're learning widget inputs, that's what I will call this one. As you have seen in previous lecture, here is where we put together a dictionary that defines our input. This input can be an existing type, like image, as we have had before, or if we enter something unique, like this, for instance, we get our own unique input type, and Node will render this way. Key value pair inside our dictionary are string and tuple, with a string inside it. So when Comfy reads the string inside tuple, its user interface is programmed to enforce alignment when making node connections. I'm using big words here, but you know this from experience. You cannot connect VAE output to conditioning input, right? In our case here, end user is prevented from connecting this input to a node unless that output matches my own type exactly. I did not explicitly say any of this in previous lecture, but hopefully you would have discovered this as you did your assignment. Programming is no different than learning maths or physics. You cannot learn by watching someone else do it or talk about it. You must do exercises or experiment with it yourself. And what about key? What does key do here? As all dictionary keys, our key must be unique. In context of Comfy UI, however, what key does is it determines the text you will see by default. You can see this for yourself, so go ahead and rename this into something, make something up. Once you restart your browser and Comfy, you will notice this change reflected in your node. Of course, this doesn't change what the node can connect to. It is only affecting its default label. The actual input type is declared within tuple. And if you right-click on the node slot itself, you will see that input type has indeed not been changed. Now, let's try something different. Instead of input type being a single string, let's make it a list of elements enclosed in square brackets like this, say 1, 2, 3 numbers. We might as well change the key as well. Let's call it int choice, int being integer. When you run Comfy, this will be the outcome. First, congratulations, you have made your first widget. You can use left and right arrows to change the selected value, or you can click on the number and pick the value from there. Also, we are not restricted to just choosing from integers. We can make a list of strings as well. In this case, when you start up Comfy, your node will appear this way. But what are these square brackets? We have not encountered them before. When you list strings or integers or some other type of data within square brackets, that data structure is called, well, list. So it is a built-in data type that represents ordered collection of items. You create them by placing a comma-separated sequence of items within square brackets. As was the case with dictionaries in Lecture 1, items inside of a list can be of any data type, including other lists. So as we had nested dictionaries, we can also have nested lists. Now, at this point, you might be thinking, wait a minute, Marco, didn't you say ordered collections of items are called tuples? So we have two kinds of collections and they're both ordered. What's the point? Why? So you see, the key difference is this. Once you create a list, you can change its content after creating it. Indexing in Python starts with 0, so if we want to change the third element in the list, we can assign it directly using this syntax. This is perfectly fine. Cherry will be replaced by pineapple in this example. On the other hand, once you create a tuple, its value cannot be altered once created. To Hawaiians out there, it pains me to tell you this, but if you attempt to add pineapple on a pizza, Python will rightfully prevent you from doing so, and you will get type error of this kind. It is by design. We don't have time to deep dive into this, but anyone who wants to know more, this property is called immutability, so feel free to look it up. It is very important. At this point, you can hopefully see where I'm going with this. Whenever you decide to use, say, Dreamshaper to create a character who is a wizard, who is in this particular pose, who is casting chronomancy magic, and so on and so forth, all these widgets operate in this way. So I'm not teaching you some useless theory. You are learning how all these nodes familiar to you are actually implemented. And because lists are mutable, we can change their value dynamically. You might have 3 checkpoints in your folder at one point. You decide to add another one, hit refresh, and voila! The newly added checkpoint is suddenly there. Of course, there is still the issue of how do we get the list of strings? We need to be able to extract names of files from a given folder and store each name as a string inside of a list of strings. Normally, this would require some work, but fortunately for us, we have a community of very smart people who have done much of this work for us. So Python files you see in root directory contain many useful functions and classes that we can access. If we look at folder paths.py, there is a function doing exactly what we need. We just need to import it in order to access it. And the awesome thing about Visual Studio Code is you don't even have to open the file. What you need to do is open your own file, the one where you want to use the actual function. You begin by typing from folder paths, import. Now let me show you a trick you can do in Visual Studio Code. If you hold down Control key on your keyboard and then you press spacebar, what happens is you will get this context menu appear. It will list various imports you can make located inside folder paths.py file. How awesome is that? So Visual Studio Code knows what file you are attempting to access, it reads it, and provides you with a list of imports available to you. The import we want is this one, get file name list. So you click it or use keyboard to navigate to it. Once you do, this function should be available to you. Function itself does exactly what the name says it does. It returns the list of file names. If you provide it with argument checkpoints, you will get the list of checkpoints. We then assign the list to a variable, ckp list, and replace the earlier list of strings with this new variable. You run the code, refresh your browser, load your node, and huzzah, we made it work. I can choose the checkpoints using arrows, but I can also click on it to pick from the list. As you can see, using built-in functions has many advantages. First, it saves you time. Nodes are less likely to break with updates. And also, what if I told you that none of my checkpoints are actually within CompUI folder. So this cyber-realistic LCM checkpoint you see there is actually not in that folder. Remember this file? If you recall, this is where you specify additional directories where to look for models, right? See, this is yet another advantage of using ComFy's built-in functions for common tasks. These functions will account for things that perhaps you would have forgotten if you were writing it from scratch. You can get a list of LoRa's in the same way, as well as ControlNet models. If you want to know what other arguments you can provide this function with, just open folder paths file and see what is there. I will add one exception though, which is list of VAE files. I am not really sure about this one, to be perfectly honest. Developers seems to have left a note here. To play it safe, my best advice is to import VAE loader class as shown here, and once you've done that, use VAE list method from within the class as I am showing here, because this is how the developer is getting his lists of VAEs in their node. Look, maybe using get file name list would work. I have not tried it, and look, if you do and it works for you or otherwise think we should, leave us a comment. And before we wrap up for today, there is something I forgot to mention in previous lecture, which is naming conventions used in programming. So it is pretty self-explanatory here. So snake case is all lowercase with underscores. Camel case kind of resembles a camel with a hump. Pascal case, screaming snake case. So if you're a visual learner, maybe this pretty graphic by Alison Horst from X, I will leave you with that and maybe that will help. Your assignment is to complete this week's node. Node should have 4 widgets altogether, each correctly listing checkpoints, LoRa's, VAEs, and control nets from your directories. If you want, you can go ahead and import functions as well if you want to try that. Otherwise, we can cover it in the next lecture. GitHub repo should now be operational and include all my settings, environment, and solutions to both assignments. All right, so we can probably leave it at that. Class dismissed.